Today we're going to talk about quadratic key features. Quadratics are where the highest exponent in your equation is a 2, so x squared. The key features we want to look at are our axis of symmetry, our zeros, our solutions, our maximum and minimum values, our vertex, and our y-intercept. So the graph of a quadratic function is called a parabola. And I'm going to move this. There we go. So a parabola. That's it, like U shape. Okay, when it's opening up, it looks like a U. When it's opening down, it kind of looks like a hill or a mountain. Okay, quadratic standard form, y equals ax squared plus bx plus c. Now, y could also be f of x. Okay, and that ax squared plus bx plus c, that's the same thing we had when we were multiplying binomials. That was our result. Or when we were solving quadratics and we were factoring or putting that for our quadratic formula. So it's the same thing. We're going to use some of that now when we're trying to find some of these key features. Okay, so first thing we want to do is actually look at a parabola and identify the parts of the parabola. The ones that we're most used to, the y-intercepts, that's where it crosses the y-axis. We're only going to have one y-intercept for every quadratic function. Okay? It can only cross the y-axis one time. Then we also have the x-intercepts. Now, when we talked about solving quadratic equations, we called the x-intercepts roots, zeros, x-intercepts, and solutions. We use rocks to kind of remember all of those. Okay? So it's still wherever they cross the x-axis. And on a quadratic, we could have up to 2 of these x-intercepts, or solutions, or zeros. Okay? So we've got one here, one here, one here, one here. These are all under the ROCKS acronym. Okay, they're all our roots, zeros, x-intercepts, or solutions. Okay? Then we have our axis of symmetry. The axis of symmetry is pretty important. It goes through what we call the vertex. Okay, so the vertex is this point right here where our quadratic changes direction. Okay, if it was going up, now it's going to go down. If it was going down, now it's going to go up. Okay, so that vertex point. And through that vertex point, this little dashed line that's kind of invisible, is our axis of symmetry. When we talk about the axis of symmetry, it's always as an equation, an x equals equation. Okay, so our axis of symmetry. And you notice how both of these parabolas, all of the titles are the same. The only difference is where that vertex is. Okay, they all have a vertex. They both have solutions. They both have an axis of symmetry. They both have a y-intercept. The difference is going to be where that vertex is. If the vertex is at the bottom of the parabola, it's a minimum. Minimum. If it's at the top of the parabola, it's a maximum. Okay, because that's the maximum height it could be. Okay? So when we're talking about our minimum or our maximum, that's going to come from that vertex point as well. Our axis of symmetry is also going to come from that vertex point. Okay? So let's talk about actually graphing these parabolas. Okay, we're gonna, first things first, take our example, y equals x squared minus 4x plus 5. Okay, if we put this in the calculator, if you put it in your calculator, look at your table, or even put these in individually, you would get, go look at your table, -1 is 10, at 0 you get 5, at 1 you get 2, at 2 you get 1, and then 2, 5, and 10. Okay? All right, so these are our points. So I just got these by going to the calculator to y equals, typing in my quadratic equation, and then going to look at my tables. Okay? All right, so we can use this to graph our parabola. So I'm going to start with this point here in the middle. I'm going to start with my vertex. And I know it's my vertex because if I look at the y value, all of the other y values repeat around it. So the 2 and the 2, the 5 and the 5, the 10 and the 10. This 1 is the only one that doesn't repeat. So this is my vertex. Okay, so I'm going to put that at 2, 1. All right. Now, as part of my vertex, it's going to give me a couple of pieces of information. The 2 right here is going to be my axis of symmetry. Okay, so at x equals 2. I'm going to go ahead and dash in my axis of symmetry there. And then now this 1 is going to be my minimum or my maximum, depending on how my parabola opens up. Okay? So let's go ahead and graph the rest of it. We can tell whether it's a minimum or a maximum. So at 1, I get 2. And that mirrors over here at 3, where x is 3, sorry. Where x is 0, I get 5. And that mirrors across that axis of symmetry when x is 4, y is 5. And when x is -1, y is 10. That mirrors across the axis of symmetry when x is 5, y is 10. Okay? That axis of symmetry, just like the name implies, causes it to be symmetric on both sides of the vertex. If you remember back to elementary school when you first learned about symmetry, symmetry means you can fold something in half and the two halves are exactly the same. On a parabola, if you fold it in half at the vertex, that would be your axis of symmetry, and both sides of the parabola are exactly the same. So each of the points around the axis of symmetry are mirrored, so they're equidistant. So if I go 2 units away from the vertex at either side, if I go 2 units to the left of the vertex, that y value will be mirrored 2 units to the right of the vertex as well. Okay? All right. So now that we've done that, we see that we have a minimum because that vertex is the lowest point on the graph. All right? I want to look for my zeros. I want to look for where it crosses the x-axis. Because there's this big gap between my parabola and the x-axis, meaning it doesn't touch it, there are no zeros, which means there's no solutions either. Okay? Now here's the cool thing about parabolas. The domain of any given parabola, barring situations, if there's a situation that changes things, but just a regular, just a regular little parabola out in the wild, the domain is all real numbers. Okay, so x equals all real numbers. For the range your vertex, your minimum and your maximum part of the vertex is going to be either the highest number or the lowest number in your range, because that's the number we're going to use for the range. It's going to be y, and in this case, because it's going up, greater than or equal to, and then our minimum. Okay? So if we have a parabola that opens up, the range is y is greater than or equal to the minimum. If we have a parabola that opens down, the range is y is less than or equal to the maximum. Okay? So minimum and maximum depend on whether it's the top of the parabola or the bottom of the parabola. All right, I'm going to go to the next page. You should flip to page 4 in your packets. Okay? All right. So for this one, we have y equals negative x squared plus 2x minus 1. Okay, now again, I went ahead and put these in the calculator. Go to y equals, type in our equation for our negative x squared plus 2x minus 1, and then do second graph to go look at your table. And the points you're going to get, negative 2, your y is negative 9. At negative 1, it is negative 4. At 0, it's negative 1. At 1, it's 0. And then we repeat again. Okay? So, our vertex. Our vertex is right here at 1, 0. Again, my y values repeat around it. So, I have this 1, negative 1, negative 1. This negative 4, negative 4. This negative 9, negative 9. But that 1, 0, that's my only one like that. So that's my vertex. Okay? If I graph my vertex, it's right there on the x-axis. Okay? I remember this one right here, this is going to be my axis of symmetry. Okay? So x equals 1. And the 0 right here is going to be my minimum or maximum. Okay? And we will decide whether it is a minimum or a maximum here in just a moment. Okay? So we know it's going to be 0. All right. When we graph the rest of these points, 0 is at negative 1 and 2 is at negative 1. I forgot my axis of symmetry. Here is my axis of symmetry for x equals 1. All right. And then we've got 3, negative 4. That mirrors over here at negative 1. And negative 2, negative 9. And that mirrors over here at 4, negative 9. Okay. So you notice we're making some nice pretty U shapes here. Okay. Our zeros, we only have 1, 0. We have our 0 here at 1, 0. Our solution is at 1. Okay. Our domain, again, without a situation, our domain for a quadratic function is all real numbers. And our range, this time we have a maximum. So our range is going to be y is less than or equal to our 0. Okay. So we have a maximum because it opened down. All right. So there is our key features for a quadratic equation, quadratic function. Okay. At this time, you need to work on the assignment in your packets, pages 5 and 6. All right, guys, I will see you later. Have a great day and do your work.